NASA's highly anticipated James Webb telescope has been in operation for several months, and astronomers worldwide are renewed with excitement due to the groundbreaking discoveries it makes every passing day. The mission has been years in the making, with billions of dollars invested in the hope of uncovering new information about the universe surrounding us. But what if I told you that the mission could already be doomed to disappointment? The James Webb telescope was designed to explore exoplanets, planets outside our solar system. One of its main targets was the TRAPPIST-1 planetary system, discovered in 2017, and is believed to have 7 Earth-sized planets. Scientists have been eager to study TRAPPIST-1, hoping to find signs of habitability and potential extraterrestrial life. But new findings suggest that TRAPPIST-1 might differ from what we thought it was, and that could mean the telescope may already be in trouble. NASA scientists have been poring over data from the TRAPPIST-1 system, and what they have found is unsettling. The implications could be significant not just for the James Webb mission, but for future space exploration as well. Uncover more secrets of the universe by clicking like, subscribe, and hitting the bell icon so that you don't miss what we find next. This is Over Orbit Plus. Let us begin from what we know. The universe is vast and mysterious, and one of its most fascinating secrets is the TRAPPIST-1 system. At the heart of this system is a star that defies convention and challenges our understanding of planetary habitability. M-dwarf stars are the most common type in the galaxy, accounting for over 70% of all stars. They are smaller and cooler than our Sun, and as a result, they emit less visible light and more infrared radiation. This makes them difficult to observe and study, but also means that their habitable zones are much closer to the star, where temperatures are suitable for liquid water to exist. TRAPPIST-1 is a prime example of an M-dwarf star, located just 40 light-years from Earth. It is about the size of Jupiter and has a mass of only 9% of our Sun. But what really makes TRAPPIST-1 interesting is its planetary system. It is orbited by at least 7 Earth-sized planets, all located within its habitable zone. 3 of these planets are preferably located in an area known as the conservative habitable zone. This makes the system a prime target for scientists searching for signs of habitability and potential life on other planets. Where do we stand? Initial observations of the TRAPPIST-1 system were very promising. Scientists believed it was an ideal candidate for potential life and were eager to study it further. It also provided astronomers with a rare opportunity to study 7 rocky, Earth-sized planets orbiting a nearby star, which is a rare find. The planets were detected using the transit method, which measures the slight dimming of the star's light as a body passes in front of it. This method can reveal the planet's size and orbital period, but not much else. To learn more about the TRAPPIST-1 planets, astronomers needed to use other techniques, such as spectroscopy, which analyzes light emitted or absorbed by an object and can reveal its chemical composition, temperature, and other physical properties. For exoplanets, spectroscopy is often done during a secondary eclipse, when the planet passes behind the star as seen from Earth. At this moment, the starlight filtered through the planet's atmosphere can be used to detect the molecular signatures of its gases. However, spectroscopy of exoplanets is challenging, as the planet's signal is much weaker than the star's and requires high-precision instruments. The Hubble Space Telescope, for example, could only detect water vapor in the atmosphere of one of the TRAPPIST-1 planets, TRAPPIST-1d. And even that result was uncertain. On the other hand, the James Webb Space Telescope was designed to be much more sensitive and capable of detecting a more comprehensive range of molecules. So as exciting as the discovery of the TRAPPIST-1 system was, it always had a big question mark surrounding it. Could any of those 7 planets actually support life? Well, the first results from the James Webb Space Telescope are in, and they're not exactly encouraging. The telescope scrutinized one of the planets, and scientists were underwhelmed at the discovery that it wasn't teeming with life. So, what's the deal? How did JWST manage to come to this bleak conclusion? The answer lies in the planet's atmosphere, which the telescope scanned using remarkably sensitive infrared instruments. It found an atmosphere with a plethora of nasty gases like methane and hydrogen cyanide, and while those might be perfectly fine for some hardy microorganisms, They're not exactly conducive to complex life as we know it. Additionally, while M-dwarf stars are the most common type of star in the galaxy, they also have several characteristics that make them less favorable for habitable planets. One major issue is their high activity levels, including frequent flares and eruptions that can damage planetary atmospheres and expose any potential life to harmful radiation. Another issue is the planet's proximity to the star. Because M-dwarf stars are cooler than the Sun, their habitable zones are much closer. This means that the TRAPPIST-1 planets are all tightly packed, with orbits much closer together than those in our own solar system. This can lead to gravitational interactions that cause the planets to become tidally locked, meaning that one side always faces the star while the other is in perpetual darkness. This can create extreme temperature differences, making life difficult to exist. The planet's composition is also not so ideal for life. Recent studies have suggested that the TRAPPIST-1 planets may lack volatiles, such as water and carbon dioxide. This could be due to the star's highly erratic activity, which could strip away the planet's atmospheres and prevent them from retaining volatile compounds. Indeed, studying the TRAPPIST-1 system and other exoplanetary objects is a complex process that requires careful attention to detail and collaboration between scientists. This collaborative approach is essential for making progress in exoplanetary research and unlocking the secrets of these distant worlds. It is a reminder that scientific progress is not a solitary pursuit, but a collective effort requiring teamwork and collaboration. As we look to the future, we can only imagine what other incredible discoveries await us in the vast expanse of space. The James Webb telescope has already proven to be an invaluable tool for space exploration, and we can only hope that it will continue pushing the boundaries of our knowledge for many years to come. Join us next time as we continue to uncover the mysteries of the cosmos. Like, subscribe and turn on the notifications so you don't miss a thing.